Okay, so what you're really working with here and what you want to look at is this. All right, and then I'm going to go select a formula that looks like this. The sine of pi over 12 can be written as the sine of pi over 3 minus pi over 4, because this is the same thing as pi over 12. Everybody with me so far?
Yes.
Okay.
Sure.
True fact. Okay. The formula we will use looks like this. The sine of A minus B, because it's an angle minus another angle. Okay? Well, let's go write down the formula. So the sine of A minus B, if you're looking at your formula sheet, or the sine of U minus V, is going to be the sine of A. Let me look at it. Oh, this hurts. The cosine of B, or U or V, whatever, minus the cosine of A times the sine of B. So make sure you can see on the formula sheet where I found that. It is the formula for the sine of A minus B or U minus B. It's the sign of the difference. Y'all see it? Yeah? Okay, I'm making sure because that's like half the battle here. So now let's plug in, if this is A and this is B, let's plug all that in the formula. So sine of pi over 3, because that's A, times the cosine of B, which is pi over 4, minus the cosine of A, which is pi over 3, times the sine of pi over 4, that's B. So notice I just took all the A's and replaced them with this A, and I took all the B's and replaced them with this B. Everybody tracking so far what I did, why I did it? Yeah? Okay. Well, this is fine because this I can find the sine of pi over 3 on my unit circle. So let's do that. Pi over 3, the sine is root 3 over 2. So I'm just going to replace that. The sine of pi over 3 is this number, times the cosine of pi over 4, which is root 2 over 2. So I'm going to replace the cosine of pi over 4 with that number. And then I'm going to continue through the formula in the same way. Let me move this up a little bit. Okay, what's the cosine of pi over 3? 1/2. That's much better looking than what we have been getting. And the sine of pi over 4 is root 2 over 2, I believe. So at this point, this is the answer, except it's not simplified yet, okay? And please remember that you will not have a calculator. So this is the answer. This is the trig part is done. The trig part is done at this step, but you still have to simplify it. And so I'm going to remind you of some rules in a second about, you might not have seen in a couple of years since Algebra 1, okay? So this will actually, this first part, root 3 times root 2 is root 6. And then in the denominator, 2 times 2 is 4. Minus, then I'm going to multiply these two fractions together. 1 times root 2 is simply root 2. And again, the denominator's 2 times 2 is 4. Well, we're almost there. I'm going to combine those two fractions, which should be simple enough because they have a common denominator already, right? They have a common denominator already. So your final answer here would be root 6 minus root 2 over 4. And this is the exact value of the sine of pi over 12. Not the decimal approximated and rounded value, but you can just punch in your calculator and get. All right, there's this. So let me remind you of some of the rules of simplifying radical expressions. let's use this as an example first. I've got the root 3 times root 2. The way you do this is when you are multiplying them, you can combine the operation under the radical. Right? You can just do 3 and just combine it into 1. I'm going to show you some different ones. So let's say we have root 3 plus root 2. Now these work like variables. The only way you can combine like terms here is if they have the same number under the root. So this does not simplify any further, right? This is kind of like, x plus y. It doesn't simplify. It's just x plus y. This is like x times y. It's just x times y. I just multiplied the two things together. Then we got one more type that you'll see. Let's say we have root 2 plus root 2. Now you're going to operate on this just like x plus x, which is 2x. So this will be 2 root 2. The like term component of this is having the same number under the radical. If you multiply, you just smash it together under the same radical, okay? If you're adding, you have to have the same number under to combine. Let me give you another example like this. Let's say we had 2 root 3 plus 3 root 3. That would be 5 root 3. I just add these coefficients, just like a variable. And you would think here, 2x plus 3x equals 5x. So it works very similarly to those kind of things. And I say that because you will just need those skills. The operations with the radicals will be ramped up a little bit. So this is review of radical operations. Does not seem very radical to me over there. All right, let's do this one. So notice in the first problem, I gave you the angle and then I split it up for you because I don't expect you to be able to reverse engineer those fractions. But I do expect you to be able to reverse engineer just a plain number. And what I mean by that is if you want to find the exact value of the tangent of 75 using the sum and difference formulas, is that on the unit circle? No. So we're going to rewrite that as a sum or a difference. So that'll be, you'd have to figure this out. I know I can write it as 30 plus 45. Those are both on my circle, right? So that's my first step, rewrite as a sum or difference. It doesn't matter which one. If you could find two numbers that you could subtract that'll do the same thing on the unit circle, then that's cool. It's going to work. All right. So basically, and I'll use u and b this time since that's what you've got on there. So really we can think of this in terms of the formula as tangent of u plus b, which is fine because I have a formula that looks just like that, okay? Let's go find it on our formula sheet. No, it is a plus b on there, isn't it? Let me change it. My bad. I'm trying to keep it as close to what y'all are looking at without changing variables as I can. This is tangent of a plus b. And that is equivalent to tangent of a plus tangent of b. And this is why I wanted you to have your formula sheet out so you could kind of see how I was selecting the appropriate formula. 1 minus tangent a times tangent b. Because I'm sure you can anticipate at this point, this one's going to be a little uglier than the last one because it's got some fractions in there. So what I'm going to do is I'm going to partially get done with this one, and then I'm going to go back and show you how to simplify algebraically a little later. I'm going to get you to a checkpoint, and then I'm going to explain kind of where the algebra begins and the trig has ended. Okay. So A is 30 and B is 45. Do y'all see why that's happening? Okay, cool. So really, let's just rewrite it with numbers in it. This will be tangent of 30 degrees plus tangent of 45 degrees all over 1 minus tangent of 30 times tangent of 45. Well, and then I can head to the unit circle and get these values. What is the tangent of 30? Well, that's root 3 over 3. Plus the tangent of 45, which is just 1, right? Okay. And then let's do the denominator. Notice we're going to have fractions inside of fractions here. So now this is 1 minus the tangent of 30, which I know is root 3 over 3, times the tangent of 45, which is 1. Okay. At this point, and I'm about to highlight it for you, this is the answer, but it is not formatted correctly. The trig is done at this point. Okay? Now, the algebra required to write this as a single fraction with no radicals in the denominator is another story entirely, okay? And I'm just going to do it. And then I'm going to go back and explain what I did because you may be upset. So I'm just going to do it. I'm going to write the numerator with a common denominator so I can add those things. Then I'm going to write the denominator with a common denominator so I can subtract those things. And so I'll have, 3 plus root 3 over 3 on top. And then on bottom, I'll have 3 minus root 3 over 3. And I'm going to move fast here because I'm going to go back, okay? So at this point, to divide two fractions, I'm going to flip and multiply by the reciprocal in the denominator. I'm intentionally moving quick. These will cancel, and I'm left with 3 plus root 3 over 3 minus root 3. So you'll have plenty of time to catch up and write down because I'm going to go back and explain. Now it's pretty simplified, but I have the additional problem of having a radical in the denominator, and so I'm going to multiply by what we call the conjugate. You'll remember this from complex numbers. And I'm going to explain that again, okay? Like I said, in first block, everybody was like, I was like, no, we're going to calm down. So I'm going to multiply these two things together, FOILing or distributing. 3 times 3 is 9. 3 times root 3 is 3 root 3. 3 times root 3 here in the middle is again 3 root 3. And root 3 times root 3 is simply 3. Here on the bottom, 3 times 3 is 9. Then we'll have plus 3 root 3 multiplying the outer terms, multiplying the inner terms, minus 3 root 3, and multiplying these final terms, I'll have, negative 3. Keep going. All right. And again, I'm going to go back and explain. These two middle terms drop out because 3 root 3 minus 3 root 3 is 0. Combining like terms on the top, 9 plus 3 is 12. Combining the two center terms, that's 6 root 3. And 9 minus 3 is 6. Simplifying here, I'll have 2 plus root 3. All right, let me go back and talk to you about all of this. Okay. That was possibly traumatic, and I'm sorry. So, again, the trig ended here in red. The formula has been applied. If you plug this into a calculator, you will get a number. Your calculator will do all this for you. But what we have to do in order to simplify this is I have to find a common denominator in the numerator. and combine these two things. Why did I write 1 as 3 over 3? Yeah, that's 1 with a denominator of 3, correct? 3 over 3. If your denominator is 4, you would write 1 as 4 over 4. So that enables me to combine these two fractions into a single fraction, 3 plus root 3 over 3. Then I do the same on the bottom. I rewrite this 1 as 3 over 3 because that's what my denominator is, 3 over 3. Then I can combine these, and it's just 3 minus root 3 over 3. So at this point, I need to divide the two fractions. And to divide two fractions, I keep the top, I multiply, and I flip the bottom. Keep, change, flip. Right? Keep the numerator, change division and multiplication, and flip it over. From there, these two cancel. It's 3 in the numerator and the denominator. And this is the combined fraction in blue. The only problem with this is that there is a root in the denominator, which we know is not allowed. Okay?
Could you have multiplied by 3 minus square root of 3?
If you multiply by 3 minus square root of 3, it will eliminate the root in the numerator, not the denominator.
Okay.
So when I have something like this in the denominator, it's not enough just to multiply by the root, man. It's going to leave a root down there. You have to multiply by the conjugate. So some examples of conjugates. If I have 2 plus root 2, the conjugate is 2 minus root 2. If I have 3 plus root 5, the conjugate is 3 minus root 5. If I have 7 minus root 2, the conjugate is 7 plus root 2. So you just write it over again with a sign change right here. Then you FOIL it or multiply it or whatever you have to do, and in doing so, it makes that root term drop out in the bottom. It's just a trick we use. You do it the same way every time. This is the conjugate. So you choose it appropriately. If this was 3 plus root 3 on the bottom, I would have chosen my conjugate to be 3 minus root 3. And from there, it's just applying these rules that I showed you how to apply. Like if we could combine these terms, that's a 9 and a 3. I know what that is. If I'm then combining these two middle terms, that is 3 root 3 plus 3 root 3, which we talked about. That's just 6 root 3. So that's where I got this. And then on the bottom, 9 minus 3 is 6. And then this last step here, when I simplified, you can either simplify in a triangle like this, or I like to think of it like this. I split the fractions up and then cancel. Right? And that'll just be a 2 up on top. I do not care how you achieve it, but you're going to end up here. So the trig formulas aren't so bad, but the tangent ones get really nasty with the algebra simplification. So here's the good news. If you can get here, that's half credit. Okay? So don't panic, but don't. Okay? If you can get here, I'll give you half credit. But you really need to endeavor to get through this because it's, those algebra rules are important. Okay. Now that you are depressed, you can do it. It seems like so much, and I will do a couple more of those with you, just the simplifying part if you would like. I'll do that after these examples are over, so those who are comfortable can go ahead and start on their work. Okay. So example number 3 says, hey man, given this in black, find the exact value. If you look at this, you'll notice that I just gave you the other part of the formula instead this time. And if you are putting your eyes on those formulas, you will see that one of them is sine minus cosine. But this one's sine, cosine minus cosine, sine. So which formula does that happen in?
Sine, this is A minus B.
Okay, so that's the difference formula for sine. That's sine A minus B. Make sure you can see that. Because you've got several patterns. If you're looking at A plus B for sine, it's sine, cosine plus cosine, sine. If you're looking for A minus B, it's sine, cosine minus cosine, sine, which is this one. And then the cosines are cosine, cosine, and here I have cosine, sine. So you're going to have to look and see the pattern, right? Without looking at it, hearing me say it just sounds like a bunch of gibberish. So this is actually the formula for sine of A minus B. So let's look at this part and identify based on that formula. This would be sine A times cosine B, right? Minus cosine A sine B. So what is A? What is it? 42, right? What's B? Yeah. So look, we can actually write this as the sine of 42 minus 12, which is, what's 42 minus 12?
30.
That's on my unit circle. Well, you gotta go find it, right? What's the sine of 30? 1/2. That's it for that one. So this is just the reverse of what we did earlier. Earlier, I gave you this piece, and you had to use this piece. And in one like this, it's much easier because I give you all of this, and you just have to figure out the formula to use. Yes, ma'am.
So with sine, the answer would be 1/2.
The 1/2. Because it says to find the exact value. Let me make a distinction. This is the exact value. This is what you call being written as a sine, cosine, blah, 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 blah. Because sometimes I'll say, write this as a sine, cosine, or tangent. And that's when you do this. And if I say find the exact value, that's when you go one step further and actually locate it on the unit circle. I have one more. We have time, so this is good. All right. One more example. Let me write it up here. I didn't get to this one in the first spot. Bless their hearts. We're going to have to do it Monday.
What did you, why don't you do the cosine too if you did the sine?
Because I did not ask. Oh, because this is not the formula for cosine.
It's 400%.
It is only a formula for sine A minus B. It won't work for cosine. That's a good question. All right, example number 4, the final example for this topic. This is a long problem. Find the exact value of sine U plus B, given that the sine of U equals 5/13, and the cosine of V equals -3/5. What that says? Yeah. And U and V are in quadrant 2. So in order to utilize these formulas, the sine of U plus V, and I really like to write that out whenever I'm looking at it. So what is the sine of U plus V? Well, that's the sine of U, the cosine of V, plus the cosine of U times the sine of V. So in order to utilize this formula, I probably need all of these things, right? I need numbers for all of those. Well, the good news is I have the sine of u, and I have the cosine of b, but I don't have these other two guys yet, right? I don't have those. Well, this is fine because I know how to find these, right? I know that in quadrant 2, let's do u. I know that that would be over here, and this will be v. Says v is also in quadrant 2. So if y'all remember this from 2 tests ago, sine is O over h, so this would be 13. This would be 5, and I would need to find this value. I really like giving y'all Pythagorean triples for these problems. So 5, 12, 13, and 3, 4, 5. You would normally do Pythagorean theorem to get that, but if you know the triple, then you can just remember it. Let's do this one. This is the A over h, right? So that would be -3 here. Here's 5, so this would have to be 4. Okay. So for u, the sine of u we already have. That's 5 over 13. The cosine of u, which I can now get, is 12 over 13. That's a over h. And so then the sine of v would be, what, O over h, that's 4 over 5. And the cosine of v I already have, right? Well, now if you notice, I have all the components I need to use for my formula. We'll go back up here. Sine u. Let me write it up top so we can see it. Let me do this. Now let's go back and plug into our formula now and I got all the pieces. What's the sine of u? Well, that's 5 over 13. Well, what's the cosine of v? Well, that's -3 over 5. Plus the cosine of u times the sine of v. Well, those are nice. At least there are no radicals in there, right? On your test, I'm going to give you some fractions that you can multiply fairly simple. The numbers will be low, okay? I won't give you stuff like 13 times 5 because who knows what that is? Not me. So feel free to plug this into your calculator right now because I'm going to give you some more simple ones. Here. Let's see what we get. It's going to be ugly, I'll tell you that. This will be 5 over 13 times -3 over 5. You really need to pay attention to the signs of the functions here because it'll really tear up your answer if you don't. I got 33 over 65. Perfect. And that's your answer. So really you're going back and you're grabbing this old skill from 2 units ago and you're using it to apply this formula. All right, then. There are not a whole lot of practice problems for this section. But they are posted in there.